I welcome you all back to another episode in Java. Today is the second day I'm teaching you all about the collections framework in Java. For today, I'll teach you the Treeset class in Java. Java Treeset class implements the set interface that uses the tree for storage. It inherits abstract set class and implements the navigatable set interface. The objects of the Treeset class are stored in ascending order. Some interesting facts about treesets are that treeset class contains unique elements only like hash set, and the treeset class accesses the retrieval times with fast intensity, and Java treeset class doesn't allow null elements. You must remember that the treeset doesn't allow null elements, and the treeset class is non-synchronized and maintains ascending order. So the treeset contains unique elements like hash set, and you can access it quite fast. Doesn't allow null elements, it's non-synchronized, and it is maintaining ascending order. Now let's dive down to a code. Alright, now let's implement a treeset. First of all, I'll make a class called main, and inside it I'll declare the main method, and after that I'll declare treeset. We say tree set, and you can see that the util class java.util class imported the treeset class. So treeset, and we'll give this the type string, and we'll give this the name tree and make it equal to new treeset. And after that we can add values to our treeset. We say tree dot add, and we'll give some string values. We say Kulesh, and another value we say Charlie, and we'll give another value tree dot add Alex, and we'll add another value called Tess. Okay, now we must use the iterator. We'll say iterator and pass it a string values as well. And next thing, we'll call this itr and make it equals to tree dot iterator. And finally we say put a while and say itr dot has next, and after that we'll put a print s out and say itr dot next. So likewise we made a treeset right now. We added the values Kulesh, Charlie, Alex and Tess to our treeset and made it iterator and printed out the outputs. Let's check the output right now. Alright, we got the output. It says Alex, Charlie, Kulesh and Tess. This is in ascending order, as you can see. It's not in the order we gave it, but it is in the ascending order. First comes Alex, then Charlie, then Kulesh, and lastly Tess. So this printed our treeset in the ascending order by default. Now let's see the way how we must implement this tree in the descending order of values. We'll put a S out here saying values in descending order, and after that for the iterator we will give tree dot descending iterator, and that's it. Now we have the while that prints the iterator dot hash next, and finally the sout prints itr dot next. Now let's see the output for this example. We got Tess, Kulesh, Charlie and Alex in descending order of values. First comes Tess, then Kulesh, then Charlie, lastly the last value in the descending order, Alex. That's how we give the values in descending order through the iterator for a tree set. Now let's see some methods for the tree set. We will now learn about the poll first and poll last methods in the tree set. First of all, let's remove this code. And finally, we will say class main, and inside it we will give the main method. And after that we will say tree set, and we will give this the type integer, and we will call this str, and we will make it equals to new tree set. And finally let's add some values. Let's add 23 str.12 str.add 56, and finally str.add 101. Now let's give some souts. Let's print str.poll first, and after that let's print sout str.poll last, and let's print this and check the output. We got 12 and 101. So the poll first removed 12 and poll last removed 101 from the tree set. Now let's print to check this out. We will put a sout and print the str. Let's run this again. We got 23 and 56, the only values that are there after removing the first and the last value. That's how this works. That's how the poll first and poll last methods work. Alright guys, now I have given another example for the tree set. I have declared a string tree set and added A, B, C, D, E and E, and then I have printed the set by the initial set name, and then set is printed as the set.descending set for the reverse set of this set, and then we have given set.headset C and inclusive true. After that we have given a subset saying set.subset A and from inclusive false, and later we have given tail set and said set.tailset C inclusive false. Let's run this and check the output, and let's understand about this code. We got the initial set as A, B, C, D, E as expected, and the reverse set as E, D, C, B, E and A. And for the head set we got the values A, B and C, because in the head set it says to print the values from before C, and true means we must print C as well. And after that the subset shows B, C, D, E and E, which are the values after A, and the from inclusive makes this flow false, and the two element is E, So the values between A and E are printed here. And finally, the test set prints values after C. So the inclusive false makes it unable to print C but only D and E. That's what happened in this code. Now we'll see some sorted set operations for the tree set. We have added A, B, C, D, E to the tree set, and we have, like before, initialized the set as set, and the head set is given as set.headset element C, and after that subset is given as set.subset between A and E, and finally a tail set is given as tail set from element C. Let's print this and understand this code. We got our initial set as A, B, C, D, and E, and the head set printed values before C, and the subset printed values between A and E without E, and the tail set printed the values from C to E. That's what happened in this code. Now I'll teach you another example regarding the tree set. First of all, I must warn you that you shouldn't be confused or scared. This will be very easy. So let's start this and let's see through this example till the end. First of all, I have made a class called book and implemented comparable to it and given the comparable type as book. And then I have made an int id, a string name author and string publisher. And finally I have given an int quantity. And next I have created a constructor out of the book class, and inside it I have declared the values. And then I have made the compare to method for the book class. I have declared public int compare to and given it book B. And then I have checked from if the id is greater than b.id, which will return 1 if that happens, and else if where id is lesser than b.id, which returns -1, and if all else fails, we will return 0. And finally we have made a main class and implemented the main method. So in it I have declared a set called book, a set of type book, and given a tree set, and I have added 3 books. The first book B1 has a book called with the identity 121 and name Aragon, and author Christopher Paolini, and publisher BPB, and quantity 8. And then book B2, which has ID 233 and the name Percy Jackson and the author Rick Riordan, and its publisher is Wiley, whereas the quantity is 6. And the last book, book 3, has an ID of 101 and the name Shannara, author Terry Brooks, and publisher McGraw-Hill, and quantity 4. And next I have added the 3 books to the set, and after that I have given an enhanced for loop with book B as the book B for set, and printed out the b.id, b.name, author, b.publisher, and b.quantity. Now let's run this and check the output. Okay, we got our output. The output shows the 3 books in order, in ascending order. First it shows Shannara by Terry Brooks and with the quantity 4, and then 121 ID Aragon of Christopher Paolini as the quantity 8, and 233 with the Percy Jackson ID 233, the author Rick Riordan has 6 books. So this is how we implement the comparable method inside our tree set. So guys, now it's the end for today's lesson, and I'll see you with another lesson another day. In the next day, I'll teach you about another collection in Java. Till then, goodbye guys, and please take care.